Okay, well, welcome everyone to the last of three panel discussions hosted by Global Affairs Canada, EDC, and MSTA Canada. The theme of these sessions is the mining industry transformed, how Canada is shifting industry norms. And well aligned with that theme is today's session called The Path to Battery Electric. It is now my pleasure to introduce our moderator for today, Nino Di Cara. Nino is the founder and publisher of Electric Autonomy Canada, the leading news publication reporting on the adoption of electric vehicles, autonomous transportation, and new mobility services. So without further ado, I would like to hand over the moderating duties to Nino. Nino, the platform is yours.
Hello and good morning, and thank you, Ryan, for the introduction. I'm delighted to be moderating today's panel. We have three excellent presentations for you, the three very different industry-leading technical solutions that will help bring greener operations to mining vehicles. The options you will hear about consist of a full battery electric solution, a conversion of existing diesel machinery to battery electric propulsion system, and a device to improve the fuel economy and reduce the carbon emissions of your existing diesel machines. Our speakers today are Martin van Koppen, Product Manager, Mine Operations of MacLean Engineering, Odd Pratt, CEO of FVT Research, and David van Claveren, Vice President, Global Sales Partner at H2 Tech. I'd like to invite members of the audience to submit any questions that you have using the Ask Us a Question function that you should see at the bottom of your screen. And if time permits, we'll bring these questions to the panel. So let's start with the full battery electric solution. BEVs, or battery electric vehicles, have been proven in mining operations, and for many, they are regarded as the future standard we should be aiming for. MacLean Engineering produces high quality and purpose-designed underground mining equipment for its global customer base, and as of early next year, the company will be offering all of its new and existing products in an electric vehicle format. So Martin, over to you.
So thank you very much for joining us this morning, and I'll just briefly take the opportunity to introduce. So MacLean is Canada's largest mining OEM, and we've been around since the early 70s, and we've always been in the underground mining field. Our whole premise is that, for starters, we won't sell you the machine if we can't support it. So we now have locations all over the world, which will come up in the next slide. And the other part is that we keep a lot of the processes in-house. So we keep all of the engineering in-house, almost all manufacturing we keep in-house, and manufacturing is happening in Ontario and soon in Mexico on top of that. So where we're located, being a Canadian company, I'm sure it's not a big surprise that we're heavily represented in Canada. So headquartered out of Collingwood in Ontario, which is about 2 hours north of Toronto. On top of that, we have branches in Elko, Nevada, Lima, Peru, Paris, South Africa, and Perth in Australia, and a network of dealers to support our customers. So we're growing quite a bit, MacLean, and not just in product offering, but also in our international sales. The products that we provide, we divide them up in three different product groups. First one is utility vehicles, which includes basically all vehicles that move personnel or material around, and will soon include a grader as well. Then we have a ground support line with our iconic platform bolter, as well as shotcrete. And then our ore flow group, which has everything to do with explosives and drilling, as well as scalers, rock breakers, water cannons, secondary ore reduction drills, etc. So quite a diverse lineup of products. And on top of that, we have three technology verticals. So we have our automation, which is essentially everything from an old-fashioned line-of-sight remote, all the way up to tele-remote operating stations. Then we have our digitization. So what do we do with data on the machine? How do we display that to the operator? How do we get the data off the machine? We now support Wi-Fi and LTE. And how do we tie that data then back into the customer databases, as well as virtual reality training simulators. So we've released our VR training simulator for the bolter, and we're currently working on a shotcrete sprayer. And that wouldn't replace all of the training, but certainly would offset some of the training requirements for operators, which saves time on the actual machine and prevents damage. And then last but not least, of course, our electrification. So that journey started in 2016, 2015 actually for the design. 2016 sold our first machine, and as of next year, essentially all of our equipment will be available in electric. And on top of that, we're now in a continuous improvement stage. So coming out with new options that bring better value to customers, more ways to customize the equipment to match it to the duty cycle. That's all in our ballpark right now. So I would say that we're past the introduction phase, and now we're in the improvement phase. And I just want to leave you with a short impression of all of the machines that are electric. We recently, last week, we formally introduced our shotcrete sprayer and transmixer to the market in EV. We have all of our boom trucks, deck trucks, step trucks already available. This is the bolter that is in operation longest. It's still working at Musselwhite, Ontario. And then a little bit of a snapshot of the design of our grader we'll be introducing later this year. We're just putting the final touches on the design right now. So that will be available in EV as well. And that's a bit of a brief introduction about what MacLean is. And certainly welcome any questions either now or later on. And I'll just flash my contact info right here. So yeah, looking forward to continue the discussion, and thanks again for joining in this.
Great. Thank you, Martin, for your presentation. If you have questions for Martin, please put them in the Ask Us a Question function, and we will put those questions to Martin at the end of the panel discussion. There are clearly some great new battery electric vehicle options, as Martin has explained, but there are obviously a lot of perfectly good diesel vehicles operating in mines that still have a good life ahead of them. So let's now look at what can be done to convert and rebuild these vehicles with battery electric propulsion. FVT began building battery electric vehicle systems for motorsports back in 2009, and in 2012 they transitioned to underground mining and now produce some of the most powerful and efficient heavy-duty battery-powered drive systems available. At its core, FTV is an eclectic mix, so I'm told, of engineers, programmers, physicists, technicians, and disruptors who all started with a seemingly innocent question: building electric mining equipment, how hard could it be? Well, let's find out. Todd, over to you.
Okay. Welcome, everyone. It's interesting that there's so many Canadian companies involved in this. I think it's spectacular that Canada is leading the charge on electrification of underground mining because it's so necessary. So I'm the CEO of FVT Research. As Nino said, we've been doing this for a while. So I'd like to show you a little bit about what it is we do, how we do it, and hopefully maybe teach you a few things too, because I think, the learning is just beginning in underground electrification. So we've been doing BEVs for a long time, since before 2010, started out in motorsports, been underground exclusively for 9 years. There's 2 locations for our company, one in BC and one in Ontario. We're also an EPROC partner that allows us to be have a larger presence. We represent their batteries as a system. And if you're not aware, Batteries as a system is a way of reducing your capex costs on your machines by essentially leasing the batteries. The large machines, batteries get very expensive. So they've got a kind of a neat system where you can lease your batteries and reduce that capex cost. We're also an FVT engineering partner, and because of that, we've got service and support for our units in 140 plus countries. So what do? We do a bunch of things. We convert diesel machines, as Nino mentioned, to 100% electric, battery power. We supply BV conversion kits for builders as well. So if we've got someone who typically will rebuild diesel equipment, we can supply a kit that can be put in for specific models and brands of machinery. We supply new utility equipment as well, and we're really good at one-offs and serial production of vehicles. The heart of the BEV is the battery. We've got a strong skill set in battery design. We've designed multiple battery packs over the past 13 years. So we've got that option, particularly when space is a real constraint, as it is on a number of these machines. We also, as I mentioned, can provide batteries from Epiroc, particularly for the larger equipment. So some nice, a nice broad variety and choice there for batteries. Okay, so a little bit about the process, because as Nino mentioned, building a battery electric vehicle, how hard could it be? I would say, and Martin would probably agree, it's very hard. So, most people think, well, you take some motors, a battery, a charger, and a little bit of magic, and away you go. There's a little more to it than that. So, starts with looking at the drive system itself. So your motors, your inverters, excuse me, gearboxes, drive shafts, brackets, all that stuff that just kind of bolts the hardware in. And a lot of people think that's an electric vehicle, but I'll tell you, it's just the tip of the iceberg. So then you got your battery pack. So if you've got batteries as service, that's a fairly straightforward part of the design. But if you're engineering a battery from scratch, typically it's about 50% of the engineering time. So it's a big part of what makes these things tick. All our batteries and the Epiroc batteries have a 2-hour charge time. And we've got 13 unique designs, and we're actually doing 2 or 3 new battery designs a year right now. Then you've got your cooling and heating systems. There's multiple systems, sometimes 4 or 5 different systems that have to be cooled. The electronics on these vehicles are very sensitive. So cooling's a big deal. Heat rejection calculations play a large role in a good design on these vehicles. Then you got your high voltage system. Most of our vehicles are 800 volt. We're working on some 1200 volt systems now. The bigger the equipment gets, the higher the voltage has to get. You got your fusing and safety systems, EMI and shielding, a lot of considerations for the high voltage system. Then you got hydraulics. This is one of our favorites because there's all kinds of new strategies that come into play. Go electric. Typically, your hydraulics are going to be run off a PTO, and you don't really have much flexibility in what your hydraulics can do when you're running off a PTO. But when you drive them separately with electric motors, you've got all kinds of new opportunities. For example, you can actually turn the hydraulics off. If a particular part of the machine is not being used, you don't have to use any power if it's not being used. So that's probably one of the most exciting parts for us is the new advances in hydraulics and powering the hydraulics with electric vehicles. Then you got the low voltage system. We say these are the veins and arteries of the machine. It's what brings the machine to life. It's the most complex part of the build. It includes all the communication data, controls, safety, multiple ECUs, very complicated. And then firmware and algorithms. Typically, our machines have got about 100,000 lines of code, hundreds of algorithms, your HMI interface for your operator, then you got telematics, safety systems, and all that. And then you put it all together, and you have about 20,000 parts. That doesn't include the machine itself, which the steel package is going to obviously add to that. You've got all the code, all the electronics, mechanical. We call it like an intricate game of chess because all these systems are independent on each other, and they all have to work together in harmony. How hard could it be? All right. This is our newest operator display. The displays are really becoming an interesting part. We've chosen a kind of a steampunk theme for our new display, which makes it kind of fun, but in behind it is a very powerful system of information. We're looking at 150 to 250 data points that are collected from, on a millisecond basis all the way up to every 10 or 15 seconds, depending on what it is we're measuring. You've got your state of charge, and this basic screen here is going to show the operator what they need to know, because things can pop up if there's any concerns on the machine at all. And then in behind, for the service techs, you've got all kinds of data that reports over telematics through Wi-Fi, fault reporting, and now our company's working on automated pre-ops, which is a big interest by some of the big companies. Right now, these are the kind of systems that are available. We've got a line of locomotives through our partnership with Clayton Locomotives in the UK, utility vehicles with some partners in Sudbury, small personnel carriers. The ST1030 from Epiroc as a rebuild kit is available now as well. For 2022, we're going to have two brand new systems, a CAT 1700G and a Toro 1400. Those will be available as a rebuild or as a kit. And then our roadmap, like Martin mentioned, we're looking at a grader as well. They're very specialized and a big challenge to electrify these monsters from the ground. And then some haul trucks, and then we're looking at some systems to go above ground as well. And here's a little history. This little cutie has been underground for about 7 years. The drive system has remained the same, but we've actually had to replace the chassis twice. So this is, some antiquated technology from one of our first designs, but it does go to show that these systems can go underground, get punished, and survive the brutal landscape underground, and do a good job. And in the future, we're getting probably 1 or 2 calls a month now. Companies that want to look at electrifying the large haulage trucks for above ground. So it's still in its infancy, but we are looking at doing some systems, working with our partner Ballard here in BC to look at fuel cells, because batteries just won't do the job when these things get 200-300 tons of capacity. So there you go. Thanks, everyone.
Thanks very much, Todd. Lots of great information there. If you have any questions for Todd, please put them in the Ask Us a Question function, which should be at the lower side of your browser, and we'll put them directly to Todd at the end of the session. By now, I hope you're planning to replace your fleet with battery electric vehicles or to convert your existing ones with electric propulsion. But in the meantime, there are, of course, thousands or millions of diesel vehicles still operating that will need to keep running for several years. So our next solution looks to bridge that gap by improving diesel fuel economy and reducing carbon emissions of those combustion vehicles. I'd like to introduce David, who is a serial entrepreneur and currently is the Vice President Global Sales for H2 Tech, a carbon abatement technology company. He has a sense of urgency for what can be done now to make a difference to reduce carbon emissions in mind, for which he believes the hydrogen technology that you're about to hear about can help bridge the gap on the path to electrification. So David, over to you.
Yes, a sense of urgency, I think, is pretty important right now to deal with the greenhouse gas crisis we have, and the path to battery electric is clearly a terrific approach for mining. There are some gaps, though. So first, I'd like to touch on the drivers for electrification. The environmental, social governance, clearly carbon emissions and as it affects greenhouse gases is a real driver. Health and safety, carbon emissions as pollutants, of course, affects the health of employees and that of the community that your mines operate in. And the last, of course, is business sustainability. What are the costs of these solutions, and perhaps what are the opportunities for the carbon economy? So keeping this in mind, what does it take to move towards a carbon-free or carbon-reduced environment in mining? And essentially, it's a fact of the matter of technology. Is it ready for broad adoption? So keeping that in mind, the first consideration is the technology itself. Does it work? Hydrogen as an ICE or as a fuel cell, battery electrification, etc. If the technology works and is the OEMs can back that up with warranties, then we have an aspect of adoption that is ready to go. And as you can see from MacLean and others, we are there. In terms of a second important component, market system. Is the market and mine infrastructure in place to provide the inputs for these new technologies as they are adopted in mining in this particular case? And lastly, what are the economics? Is it feasible? So if we have technology that works, the market system and inputs are available, and the economics make sense, then we are in a position to catch a pretty big fish. These are the conditions that allow us to move towards full adoption. So where are we at now in terms of the tar factor for mining? Starting with the light duty equipment out there, clearly today there's lots of options and opportunities to adopt logistics related equipment, fully warranted and ready to go with market inputs and such. It's a fairly small carbon footprint though, as compared to perhaps looking towards more medium duty equipment where we are going to see some of these underground solutions. And again, we've just seen two presentations where technology is ready today for the underground applications. And depending where the mine may be, the market infrastructure is either available or can be available, and the economics are actually pretty favorable. So we're looking good in that area. A big challenge in mining in terms of the readiness of adoption rests in the heavy duty equipment. When we're looking at in open pit situations, this type of equipment today, we don't really have a high technology readiness factor. And as we can see, there's research being done, and we can expect to see some developments over the next number of years. So 10 years out, I'm sure we'll see a lot of adoption in the underground mining. MacLean and everyone we've just seen today and others will be rolling this technology out. And maybe by 10 years, we'll see some good opportunities in terms of the technology readiness for heavy duty. And perhaps 20 years out, we're going to see a lot of adoption in this larger footprint as well. So there's a gap. And this gap needs to be bridged. We have that urgency right now to address the carbon crisis. We need to bridge this gap today, and that's where our sense of urgency comes in with hydrogen. Hydrogen is one of, I'm sure others, but one opportunity to bridge this gap. And what is hydrogen? Well, hydrogen is a technology that is manufactured by Dynacer, a publicly traded company here in Toronto. It develops carbon emission reduction technology that produces hydrogen and oxygen for the purpose of improving diesel combustion. And that improvement leads to two significant benefits: the reduction in carbon emissions and an improvement in fuel economy. And I can say we have won a number of awards, and we've been validated by independent third-party organizations. So the technology is ready. We have a high readiness factor. But let's look at the two benefits more specifically. Obviously, if we're going to improve fuel combustion, we're going to improve consumption. And depending on the application, because it does vary by engine, we can see a range, north of 10% fuel savings, which of course, improves operating expenses. And heck, it can lead towards investment in other areas as well in the mine. The emissions are reduced, whether it's from a greenhouse gas or from a pollutant point of view. That becomes pretty contextual. If we look at our favorite Cat 793, which is widely used in mines around the world today, we could see potentially upwards 1,000 tons per year per truck in CO2e reduction. and depending on cost of fuel and other inputs, we could see 100,000 or so in fuel savings a year. So it's pretty darn meaningful, and it's ready now. So now I'm going to turn to a short video. It's less than 2 minutes that you can see a little bit more about how the technology works. And I'm going to turn it over to Helen, who will take this at this point.
100 million diesel engines are produced worldwide. Over 1 billion diesel engines are in use today, serving a multitude of uses, from human and cargo transportation to marine vessels, to construction and mining equipment, to power generation. Dynacert delivers carbon emission reduction technologies to the global marketplace. Introducing the award-winning hydrogen technology, delivering 2 key benefits to diesel engine users. 1, reduced emissions, and 2, an increased fuel economy. Hydrogen uses electrolysis to turn distilled water into H2 and O2 gases that are produced on demand. In today's diesel engines, fuel auto-ignites several degrees before the beginning of the power stroke. When the piston reaches the bottom of the power stroke, residual energy is left unused and gets discarded through the engine's exhaust system in the form of hydrocarbon emissions. But with hydrogen technology, H2 and O2 gases are introduced into the diesel engine's air intake before the turbocharger, which produces a homogeneous air mixture prior to combustion. Introducing hydrogen gas into the air intake of the engine creates a faster and more complete combustion. This results in a lower combustion temperature, reducing NOx production and lowering other carbon emissions. It also results in the added benefit of improved fuel economy. The faster and earlier burn in the power stroke means the fuel is more completely consumed, providing better response, resulting in less wasted energy exhausted as hydrocarbon emissions. Our hydrogen technology is designed for all types and sizes of diesel engines: small trucks, refrigerated trailers, Class 8 trucks, construction and forestry equipment, power generation, heavy mining equipment, railroad locomotives, and marine vessels.
Okay, so that was a good video. Certainly he did a better job than I could have done. So it gives you a bit of insight into how our technology works. And I think a takeaway here is a diesel engine is a diesel engine to us, whether it's in trucks, tractors, or buses, off-road applications like mining, generators, or even locomotives. But getting back to our CAT 793, our favorite vehicle that's used in open pit mining, considering the price of fuel consumption in the application and so forth, the opportunities are pretty meaningful. We could see up somewhere from over 40,000 to over 100,000 in savings, depending on, of course, the fuel economy improvement. And this relates in most cases to a payback in under a year, which is, of course, highly attractive. Now, cycling back to a minute for the emissions validation by our favorite German road safety department, hydrogen did receive the homologation certification, or ABE, by testing our technology on in this particular case, a MAN truck Tier 5 engine, and we see improvements in CO2 of nearly 10%, NOx of over 80, and in total hydrocarbons, in particular, like particulate matter, over 50%, which is pretty meaningful. So I think considered together, the technology or the tar factor is quite high. Moving on to another important opportunity is really as we look at the carbon economy. Dynacert does have patents pending for the certification of carbon credits, the reduction in equipment used where hydrogen has been used, and we can monetize that when the marketplace is ready. And there's a time frame for that we need to see come to fruition, with sector standardizations and such and so forth. But there are additional opportunities with this kind of technology to monetize the investments. Looking at the line of product on the far right, you'll see the blue hydrogen unit. This is something you'll see in a Class 2.5 vehicle, one of those logistics light duty engines. All the way to the left side, you'll see a unit that would sit on a CAT 797 106 liter large heavy-duty piece of equipment. And of course, it's always important to have data analytics. We do have a dashboard which an operator will be able to see and track and monitor individual data engine, the carbon credits, and other such things as well. So from a mining point of view, where are we at? So H2 Tech has a global mandate to bring this technology to mining and significantly address this urgent need of reduction in carbon emissions. So where are we at after 2 years of moving into this market? And notwithstanding COVID, which has been quite an interesting last 12 months, we do have a trial with a Canadian company. We have one in Peru, 2 in Chile, 2 in Brazil, Paraguay, Argentina, and very soon we'll be installing in a large diamond miner in Russia, and in the last stages of putting together a pilot for a coal mine in Australia. So after a period of time, we are bringing this technology to the marketplace, which is quite encouraging. Supporting us, we have our partners around the world, which assist in sales or sell, as well as, more importantly, beyond the ground to provide installation and service for the technology. So we've come quite a way. The technology is ready and it is emerging into mining. Like any new technology, I would believe, and I think it's wise, and we do this for the next while anyway, is to offer a proof of concept where we say seeing is believing, and we will do that for you. Choose a mine, some equipment, a number of weeks, and we'll guarantee you some performance. And at that point, you'll be better understanding whether or not this is something you could use for your entire fleet. So essentially, those are my 10 minutes to talk about a bridging strategy. We all want to see electrification and zero carbon. There's going to be some time for that. And in the interim, we can do something now. So we believe we are a good choice to address that.
David, thank you very much for your presentation. And to all the members of the audience, if you have questions for David, please put them in the Ask Us a Question function at the bottom of your browser, and we'll put them to David for you. And indeed, that concludes the presentation from our 3 panelists. So if you have questions for any of them regarding their businesses or their technology, please do feel free to put them in the Ask Us a Question. I'm sure many of you would like copies of the presentations you've seen today, and I can confirm that a recording of this session will be available after the event. So let's bring the panel together for a group discussion, and I think I can see my panelists now in front of me, and hopefully the audience has a similar view of David, Todd, and on the screen. So thank you all for chatting us through your solutions. And the first thing I'd like to ask is, generally to the panel, is what are the performance implications of the solutions that you've spoken about compared to current diesel solutions? And I'll leave it open format at this stage, and for anybody who would like to take the question first.
I could start if you want.
Yeah, go ahead, Martin.
So we have the luxury that we provide both diesel equipment and electric equipment. And when we pair them up side to side, and we've done several tests now at existing operations, at test facilities, we see improvements in performance. And that's because you're no longer really limited to the amount of horsepower that you can put in a diesel engine to still be in compliance with ventilation. And so, yeah, we're seeing significant improvements in performance. And the beauty of the equipment that we provide, which is sort of on the utility side, is that a lot of times the equipment actually has to be stationary, part of its job. So whether it's to unload supplies or discharge a drum of shotcrete into a sprayer or anything along those lines, and those are great opportunities to plug in and charge while you're doing meaningful work. And that's how we see that you don't have to take any downtime for charging, which is always a big question. So that's really encouraging. One of the mines in BC that purchased one of our boom trucks, for example, They can drive up their 17% ramp, about 4.5 kilometers long, and it saves them about 20 minutes in a drive compared to the diesel unit. So it doesn't really seem like much if you do that once a day, but that truck is supposed to be up and down that ramp all day long, right? So it's a significant improvement. And then on top of that, which is maybe unique to underground mining, but the heat generation is a fraction of what it is with diesel engine. So I can go on for the remainder of this hour about all the benefits, but certainly in terms of performance, big improvements. And I think we're just seeing the tip of the iceberg. I expect performance improvements to continue to improve as components on EVs are improving along with it.
Thanks, Martin. And Todd, are you seeing a similar?
Yeah, I'll share a quick story that I think sums it up nicely. This is a couple years ago. We had a training session underground with a seasoned veteran. He'd been underground for probably 20 years. He was diesel through and through. He thought this electric stuff was ridiculous, but he was being forced to be trained and operate this electric contraption, and it was a flat deck carrier. So our trainer got him trained on the vehicle, and then he was going to operate it for the first time. So the fellow got in, seatbelted himself in, still muttering under his breath that this was a waste of time. And they had, I guess, about 10 or 12 ton of cargo on the back of this thing. So it was loaded down really well. And they headed along, started the vehicle up, headed along up a corkscrew, probably about a minute trip all the way up. And at the top, the operator stopped, and he looked at our trainer, and it was a combination of shock and delight. He wasn't expecting what he got. So the first thing he said, and he threw his hands up in the air, and he said, "There's no heat." The next thing he said was, "There's no smoke." And then he said, "And that's the first time I've ever talked to someone while I had a full load on a flat deck and was driving up a ramp," because he could have a conversation with the trainer on the way up. Didn't have to have, the hearing protection on, and well, 2 sets of hearing protection. They're pretty loud. So we tell that story all the time because that's from someone who thought it was nonsense and was converted in a matter of 1 minute by the experience, not by someone trying to convince them, but actually just driving it and going, "Wow, this is going to change everything." So that sort of, I think, sums up what electric does for the men and women underground.
Martin, is there anything you'd like to add to that in terms of the difference from a miner's perspective that they can expect to experience with the transition?
Anecdotal evidence. Did a bit of a survey when I was still with Goldcorp at Borden, and the operator feedback was, it's the first mine that I worked at where people weren't complaining about the ventilation system. Anecdotally, people felt better at the end of the shift. Less fatigue because of it could be any combination of things, stress from noise or heat or vibration, and certainly emissions fall, right? So this provides for a healthier workplace. And I think by and large, most operators, once they had a couple of shifts driving an EV machine, most operators will conclude that that's a pretty good way to go about it. And of course, there's some growing pains here and there when you're introducing new equipment, but the responses have been overwhelming. And in the case of Borden, at that time at least, going electric unexpectedly turned into a bit of a retention strategy as well, with people who are not jumping the fence, make a little bit more money at different operations, but shows a healthier environment. So, you always kind of take it with a grain of salt on how much you can extrapolate those anecdotal stories, but certainly all positive news.
And David, considering the hydrogen solution, also using the same systems, but is there a material difference in the way that the miner would need to operate vehicles. Oh, I think you're on mute there, David.
Let me correct that. Nino, that's a great question, and let me answer it in a couple of ways. So, in terms of performance and expectations, obviously, as you saw in my presentation, we know they're going to get some financial benefits, and that's as a result of the performance of a better combustion in the engine itself, which actually leads to a couple of things. One of them is more torque. So we've actually seen engines, trucks go up hills faster, demonstrably. And so there are some interesting benefits there. But something that was real, I just saw the other day that was kind of visually remarkable, was a trial with TTC, the Toronto Transit Commission, where it's buses, but good old dirty diesel engines. And at one point they had actually did a shot of the stack as the bus launches off, and this black smoke goes billowing out of the stack, and it's quite dramatic. And that's a lot of pollutants. Wherever you are, pollutants are not good. So then a few weeks later, after hydrogen had been installed, they did the exact same video, and the bus hits the gas and it goes, and you see this tiny little bit of gray come out of the stack. It was just a stark reminder of some of the implications of using dirty diesel engines. And I can't wait to have my fellow co-speakers here have their technology everywhere. I'll hopefully be on the beach retired. But in the interim, we can make a big difference in things like that. And I think a mine operator or any diesel engine operator can see those two very real operational differences right away.
I think we've all experienced the black stack coming out, and something we're all looking forward to see diminish. So that's a good story to hear. I'd like the panelists to speak to the safety implications for Martin and Todd of battery electric vehicles underground, and David of adding the hydrogen conversion. What are the safety implications of making this? Martin, perhaps you'd like to go first.
Sure. Well, I mean, batteries, like any form of stored energy, carries a certain amount of risk along with it. But as Todd mentioned, almost all high-performance batteries that you would see in mining equipment, but certainly ours, has an abundance of data on board to monitor exactly what's going on, of battery or temperatures, voltage imbalances, currents, a whole whack of different things. And so when you start monitoring those batteries, have a real live connection with them, you can set up all sorts of early warnings. And so I would say that that's the number one risk mitigation in battery electric vehicles, is having that battery connected and keeping an eye on it. And that's by far the biggest risk mitigation. And compare that to a diesel tank, where all you have, if you're lucky, a dipstick to stay how full the tank is. It's a bit of a far cry from the technology that goes into batteries. So that's number one. And then it's really upon all the OEMs and in a whole bunch of other safety. On our end, for sure, well, everything is properly engineered with all the right documentation in place. We have things in place like, our batteries are liquid cooled, but we introduced a low conductivity coolant, live conductivity measurements on top of that, and just a wealth of testing that we've done to make sure that what we put underground is safe. And ultimately, our company was founded on. Oh, sorry, there's an Amber alert going off here. Yeah. Ultimately, our company was founded on the principles of providing safe products, proof safety underground. That was really one of the key reasons why Don MacLean started the company, and we're not losing sight of that. So it's very high on our priority list, and given all of the controls that we put in place, certainly very manageable. But it's a great topic, and it does require a bit of an educational curve to make sure that our customers understand what risks are associated, why we manage them, how we manage them, and what kind of things should be considered.
Yeah, I'd echo everything Martin said, and I'd add something. It's interesting when you produce an electric vehicle for underground, you remove one of the most dangerous parts of vehicles underground, and that's a heat source. It's pretty common for a hydraulic line to go spray on a part of the diesel exhaust system that's extremely hot, and that fuel gets ignited. That problem doesn't exist on electric vehicles. There's nothing on our systems anyway that gets over about 90 degrees Celsius, maybe 100. It's not going to ignite hydraulic fluid. So you actually kind of eliminate that, one of the biggest problems for fires underground, which is a heat source.
And maybe now I can make a comment on hydrogen, because certainly we hear a lot about how safe our technology is. We all know hydrogen is pretty explosive. I'll point out here very clearly, though, we don't use hydrogen as a fuel source. We use hydrogen in very small quantities, more like a catalyst to combust diesel better. So the concentration of hydrogen is very low, and it's generated on demand. So it's not stored in a container or vessel under pressure. So it's generated on demand at 1 atmosphere at a quantity that's almost 100 times lower than it would need to be to ignite with some sort of flame source. So in our particular case, the way we use hydrogen, it's entirely safe due to those two key factors.
Thank you. We have some great questions coming in from the audience. And Martin, I can see you've addressed some in the chat, but for the benefit of those watching and listening, regarding graders and open pit mining, are you talking about equipment like CAT 24M?
Yeah, the grader. So MacLean, really, our focus is underground mining. Years, or almost 50 years. So when we designed our own grader, we had the underground market in mind first and foremost. So the grader that we think we can outcompete on performance is the CAT 12M or Caterpillar 140 road grader, which might be a bit small for the really large open pit mines, but there could be other surface operations where there could be a good. Certainly happy to talk about it. Then I will say too that we took a little bit of a different approach with our grader, because normally you'd take a civil road construction grader and put it underground, and so there's all sorts of features that you would normally not use in an underground environment. At the same time, we took the opportunity to beef up a lot of the high wear components like the circle drive and to really make that more robust. So that's my elevator pitch. It's a purpose-designed underground grader, but of course we're looking forward to see if that could be an application for surface operations.
And related on the electrification side is obviously the issue of charging infrastructure. And perhaps Todd, if you could start speaking to some of the implications of installing charging infrastructure and kind of what the cost profile might look like.
Mm-hmm. Yeah, so that's kind of like how long is a piece of string. So it depends on a number of factors. One is whether or not you've got chargers on board the vehicle or off board the vehicle. The tendency right now in the industry is the smaller equipment will have chargers on board. The larger equipment is leaning more towards having, and I'm talking scoops and haul trucks, having charging off board. For the onboard vehicles, I know MacLean and FVT, I think we kind of see eye to eye that it's nice to be able to plug into the the big Startco jumbo plugs. In Canada, we've got 600 volts hanging like fruit everywhere underground. It's wonderful. So you don't necessarily need a charging station if your charger is on the vehicle. You need a way of lacing into the existing structure underground, electrical infrastructure underground. So Startco panels are one of our favorites. They're safe, they're proven, and so you can drive up to any of them, plug the vehicle in, and charge up. That gives you some freedom too, because you can imagine if you've got 60, 70, 100 vehicles all having to go one place to charge, it's a bit of a parking lot. You can get expensive making parking lots underground. The next one would be off-board charging, and that is going to be a situation where you're either taking the machine to a high-powered charger, which could be 3, 4, 500 kilowatts or larger, something that's not necessarily portable, or looking at a situation where you're actually swapping those batteries off. So go take the machine to a battery swapping area, change your battery, that battery would stay in charge, and then you would head off with a fresh charge battery. It usually takes 5 or 10 minutes, something like that. So there's a number of different strategies. There's also fast charge strategies. I think Caterpillar are doing something like that. But it's something to consider. What we've discovered through our mining partners is it's not as much power as you would think, and it seems to be spread out through the day fairly well.
Martin, anything to add?
Yeah, we certainly see eye to eye on that, and we also see that vehicles have different charging needs, so that's why we offer multiple options, over the charging or a lot of charging, all within the limitations of a jumbo plug. And then on top of that, what we're seeing too is that if you're looking at all electric mining operations, and there could be investments made on off-board chargers, for example, to facilitate those haul trucks or scoops or other OEMs equipment. If they have a common coupling, then maybe that makes more sense. So we are certainly preparing to put CCS2 type receptacles on our equipment. It sounds simple. But it does take a little bit of homework to make sure that that's done safely and correctly. But perhaps that makes more sense for the customer. So, and that's sort of our take. So, as long as the battery stays on the machine, we can work our way around it and work with the customer to see what makes sense. So, and that's really our realization after being in after 5 years that, no two pieces of equipment are the same, and no two projects or operations are the same. So why would you offer a one solution fits all type of thing? So that's being able to customize and making sure that it makes sense for that operation is where we see things going.
Question for David, H2 Tech. David, can you give a gap analysis for an operation to be hydrogen ready?
Oh, a gap analysis. Oh, that sounds like fun. To be hydrogen ready, the answer is very simple. In our case, they're ready. Because we are not requiring a market input of liquid hydrogen to be not just produced locally and transported to the mine site, which would be really a barrier, a gap currently for these future technologies where they're using hydrogen as a fuel source. Our hydrogen is generated through electrolysis, which is part of our unit. So we require distilled water. And so the market input is distilled water. Our unit's on site. It generates modest amounts of hydrogen at that time. But I think certainly as we look forward into the tar factor for these large duty applications, heavy duty applications, we're going to need to wrestle with the fact that hydrogen needs to be available to the mine and the infrastructure required. And there's some considerable gaps there. So I don't know if that's really part of the question, but certainly I think in the next 10 years, that's going to be a big one to be wrestled with.
Thanks. Quick question for Todd and Martin. There's a lot more to electrifying a mine than just converting the vehicles, as obviously I'm sure you well know. Do you work directly with mining companies or primarily through the engineering firms that are redesigning the mine's infrastructure?
Either one. I'm a mining engineer by training. I spent most of my career with mining companies. I love talking to mining engineers. We do a lot of work with consultancy firms or the customers directly. And you're absolutely right. There's more to it than just putting electric vehicles on the ground. Because I think where you really start extracting value is to start rationalizing your ventilation infrastructure. And that has all sorts of implications. Mine heating, for example, in Canadian mines, or mine air cooling, refrigeration plants. If you go further upstream, even power supply to site, because there's such a net positive reduction on your overall site electricity need that maybe there's all sorts of benefits there on how much power you need to get to site. So there's a lot of cost savings there to be realized, and we're happy to talk about just about anyone really, certainly including consultancy firms. We're trying to hit all of them up, or some of the major ones anyways, about once a year or more often, and it's also our job to make mining companies and consultancy firms' lives as easy as possible by providing things like expected heat generations from VAV under different duty cycles, or expected operating costs. Or certainly more than happy to work with anyone, because at the end of the day, we want to see our equipment in as many 43-101 reports as possible. That's part of my job. That's why Kevin MacLean pays me. So, yeah.
Todd, anything to add to that in your experience?
No, Martin did a great job. I think what's probably one of the more enjoyable parts of this is the education process. I mean, we're seeing very curious minds and consultants saying, "Hey, what's this about?" And just being able to educate them on, okay, yeah, you can do things like, I think we're seeing numbers of reduction of electricity usage at a mine by in excess of 40%. Which is counterintuitive. You think, well, it's an electric vehicle, electric mine. Why are you using less power? But as Martin said, the ventilation demand is far less, and you start reducing by megawatts the amount of power that you need for these big fans and air conditioning systems and that. Yeah, it starts to really add up. So yeah, we enjoy that process, and we don't have the kind of depth that MacLean does for reaching out. So we typically wait till they contact us. But I'll tell you, the phone rings on a much more regular basis now, which is very encouraging.
And so we are coming up to the hour, but because we've got so many questions, I have been given the green light to continue the discussion for another 5 to 10 minutes. So I hope that's okay with my fellow panelists here, and if you wouldn't mind just staying on the line for a little longer. Thank you. So a question for all. Are there any opportunities to gain the carbon credit by converting the existing equipment? The question is relating to from diesel to battery driven, but David, perhaps there's some application here as well.
Yeah, so if you're asking me about the application as it relates to hydrogen, the technology, Dynaster does have patents that are embedded in the ECU of our unit to actually track and monitor the carbon credit savings or realization of carbon credits as a result of using our technology. And by virtue of those patents, if you save 1,000 tons and the market price for carbon right now, let's say it's $32 US, 35 or something like that, that's $35,000 that is available through trade once the system is ready for that. So in fact, there are some pretty meaningful opportunities there as it relates to our technology.
Okay, and for me, I'm going to be honest, I really don't know. Just as a side note, when we got into this a long time ago, we thought we were going to save the mine's fuel. We thought that was going to be the big saving, and we realized that was almost incidental. The amount of money that they're saving with the ventilation costs. So I'm imagining carbon credits will be somewhere in that kind of category, but I'd only be guessing. Not sure. Martin, you may know more than this than I do.
Martin, you're on mute there.
That was just a test to make sure you're paying attention. No, I'm only familiar with Canadian jurisdiction, and so that might be different in other parts of the world. However, in Canada, last time I checked into it, there's an allowance for carbon that mines get based on their output, on the amount of ounces of gold produced, for example. And so, as you can imagine, if you're looking at an underground all-electric mine with electricity that comes from a clean grid, your carbon that you're using to produce that gold is almost zero at that point. And so I would imagine that having all of those excess credits, you can either apply it to other operations within the portfolio or possibly marketing those. But I'm certainly not an expert. I do know that there's quite a bit of value, and not having to pay taxes, I think is a good news story for also.
Excuse me. A question for Todd and Martin. What are the operating parameters of the ideal duty profile that optimizes the performance characteristics of the EV?
Yeah, haul downhill. That's it. Done. It's so difficult on especially the bigger equipment, because normally what happens is you fill your truck and then you drive it uphill. So if you can design your mine where you haul downhill, and there are a few, that's brilliant. But other than that, I mean, there's other things, like we like to see if we can get vehicles to last a full shift. Typically on an 8 to 10 hour shift, you're going to have 4 to 6 hours of actual operation, and it's ideal if you can have your batteries on board, your charger on board, and actually charge between shifts. For the smaller vehicles, it seems to work well. For the larger machines, boy, it's all over the map. I mean, some of these mines are 24 hours, and the only answer is either going to be fast charging or battery swapping, because the machines are being used continuously. Other machines are used in spurts and then sit, like Martin said, like some of the drills in that, where they can plug in and be used. So it's a bit of a mixed bag of nuts on that one.
Yeah, absolutely. I think for the type of equipment that we provide, I mean, bolters are easy to plug in anyways. But if you have a fleet of electric equipment, and you have some jumbo cables in storage areas, let's say, where those machines often stop to do some meaningful work, then those are great opportunities to plug in and get some charge, and that way you don't have to incur any downtime for charging. So that's but we have the luxury typically that our machines take a load from surface or from a high point and bring it down, and then come back up empty or with a light load of maybe some garbage or whatever it is, which is why utility vehicles might make more sense to electrify. Certainly, when you look at scoops or trucks, that's a whole different set of challenges.
David, this one relates to hydrogen, so I'll put it directly to you. How do you manage the operator, different persons on shifts, variable in the use of hydrogen?
Yeah, so the hydrogen consumption, as it were, is strictly a matter of the engine's operation, and the operator has little to do with it, other than if the operator feels there's more power or torque, in fact, they may choose to go faster. A lot of the mines control speed and other such factors of their haul trucks and things of that nature. But the operator is external to the process. The equipment runs based on whether or not the engine's running through the software and connectivity. And then we have various means to communicate with our device through cellular or Wi-Fi to maybe have some operational variables adjusted in the unit, but the operator really doesn't come into it. So operationally, it's business as normal. Gas on the right. So away they go.
Thanks. Question for Todd and Martin. And this is to quote the question. My understanding is that with BEV acquisition is equivalent to buying an internal combustion engine vehicle with all its life fuel purchased up front. Is this a fair statement? And how do you address this to encourage the purchase? And it obviously wraps into total cost of ownership.
Yeah, in a way that is true, and that the upfront investment is larger, and then drop in maintenance costs and rebuild costs, etc. But I mean, you would still use electricity, so it's just a different type of investment. I'm not sure if that comparison holds water completely. But yeah, I mean, electric equipment is more expensive up front, and you would see lower operating costs. So how that balances out kind of differs on utilization, etc. Like most OEMs, we also offer battery lease programs. I think that's pretty common now to lower the capital cost. So it's not quite a fair comparison. I think it's more fair to say they're just different, and they would have different capital or operating expenses associated with both options.
Yeah, I'd agree with that. I don't know if it's as straight. I don't know if you can connect the dots that cleanly. I do know that for say the example of batteries as a service, the lease cost of the batteries is typically about what you would spend on fuel. So you would just transfer that payment to the batteries as a service. So the vehicle itself obviously gets less expensive than if you bought the battery up front. And then you're spending about what you would spend on diesel every month for that size of machine. So maybe that provides a little more clarity.
Thank you. And David, I recall from your presentation you were saying that the solution pays for itself within a year of operation. Is that correct?
Thanks for paying attention. And it varies, as you may recall. The actual savings in fuel is quite different if you're a piece of equipment that idles a lot versus a haul truck that's going up 4-degree grade and with a couple hundred tons in the back. So and our systems, of course, the small ones not as expensive as the big ones. So when you start to do your paybacks, a number of factors come into play. I would say often the payback's under a year. Certainly, I don't know of too many circumstances where it's more than 2, for instance. And listen, I just we're working on this thing in Australia, and their cost of fuel is 40 cents a liter. That changes the payback period after government rebates. We all want to operate there, I guess. But in certain areas where you're up in the mountains at 4,000 or 5,000 meters, and you have a high cost of fuel, diesel can be $1, $1.20 US a liter. You're going to have a faster payback with our technology because it's highly tied into that. But I'll say as well, that's just the direct payback. There are indirect paybacks. Addressing very important ESG initiatives has value, but I can't put a dollar figure on it immediately. So I say that in the presentation under a year is a nice catch-all. We have to look at each case specifically and individually. And
thank you. And just wrapping up now onto the final question. We've gone into our 10 minutes, but just to ask, Todd, you mentioned you're getting more and more inquiries. And Martin and Todd, are you finding, what is the reaction from your customers who've been living with these vehicles for a year or more? And how are they feeling about the experience for the people that have actually done it?
Yeah, it might be the new religion underground. What do you think, Martin? It's
yeah, I don't know if it's a religion or just a positive experience. I think certainly from different levels, whether you're an operator or at a mine site or at a corporate office, there are just so many different good news sides or good news stories with EV that there's something for everyone. Whether you're an operator sitting in a corner office in Toronto or elsewhere. So yeah, there's just a realm of positive things. I think, and of course there's some growing pains here and there, but I would say that I'd like to think that most of our customers are pretty happy. That's what we keep hearing. So I don't know if that's worth something.
I'm sure it is. Well, thank you, Martin. Thank you, Todd, and thank you, David, for being such great panelists and really sharing your knowledge here with us today. And a big thanks to Canada's Trade Commissioner Service, Export Development Canada, and the Mining Suppliers Trade Association Canada for organising today's event. As I mentioned, a recording of this session will be made available. Thank you all for joining us today and listening to the presentation.